Welcome to Analyst Crossfire, a Supercomputing 2010 wrap-up show featuring expert voices from the HPC community giving their reactions to some of the top trends from this year's SC conference. I'm Addison Snell with Intersect360 Research, and I'm your moderator for Analyst Crossfire. Joining me on the panel today are two vendors and two users who assure me they are able to address any supercomputing topic I care to throw their way, giving us their personal views and not necessarily those of their organizations. On the vendor side, first we have Peter ffoulkes. Peter, a one-time industry analyst himself, is the VP of Marketing at Adaptive Computing. Good morning, Peter.
Good morning, Addison.
Next we have Michael Wolfe, who sees how new technologies affect programming as a compiler engineer with the Portland Group. Thanks for joining us, Michael.
Glad to be here.
On the user side, we have two esteemed and widely recognized supercomputing lab directors, each well known for their generosity in sharing their opinions. First, Jay Boisseau, director at the Texas Advanced Computing Center, or TAC. Good morning, Jay.
Good morning, Addison.
And finally, a longtime advocate for supercomputing technologies, Thomas Sterling, Arnold and Edward Professor of Computer Science at LSU. Hello, Thomas.
Addison, thanks for the opportunity.
Gentlemen, thank you all for joining me for Analyst Crossfire. Let's get started. Our first topic today focuses on the significant amount of attention being garnered by accelerator technologies at the show, specifically GPUs. 3 of the top 4 slots on the new top 500 list were claimed by GPU-driven systems, Tianhe 1A in Nebula in China and Tsubame 2 in Japan, with the US-based Jaguar system from Oak Ridge still at number 2. Jay Boisseau, what is China's role in the global HPC market, and will the US respond in some fashion?
Well, I think the U.S., of course, recognizes, as does China, that innovation is important and that knowledge discovery is important. I think that the #1 system is a system that many countries could have built. China put the effort into it. It's certainly a system that many countries could replicate and will replicate over the years ahead. But China has tremendous talent and resources, so I think they're going to be a fixture in the top 500, and especially even in the top 10 for the next several years and onward.
Peter ffoulkes?
I would agree. I think that what this shows is not so much about the technology, which now, of course, is available to pretty much everybody, but the fact that China is building their own interconnects, the fact that they are really serious, I think reflects more the global political situation. They are rapidly becoming a very major political power in the world, and HPC is part of that. On the other hand, I think that there's a tremendous education problem to broaden HPC beyond the specialist things and make that more available to the entire community around the world. And if you look at the rate at which China is emerging, it's clearly got the top-end capability, but there are a huge number of people in China that can benefit from HPC, but have a lot of education before they can get there. Will the US respond? Of course, politically. I think from what I'm hearing of the systems that people are already planning, I think are already looking that there'll be a big battle. The US has got that, and I don't think at some level it's as petty as a response. I think it's just furthering science, and the US has traditionally been the leader.
Thomas, what do you think about that, China's role, and whether the US will respond?
Well, it's clear. China wants to be first world, but they want to do that on their terms, not the world's terms. This is a case where they expect the world to assimilate to them, not they be assimilated by the world. And it's not just the flops, although it's a very impressive accomplishment. I was there just a few years ago, spoke with their technical leaders, saw their machine. Very impressive engineering and technology. What is scary is 2 things. First, as Peter just mentioned, they're developing some of their own technology. They didn't have to. They could have bought it. It would have been cheaper, faster, and more reliable initially for them to do so. But they identified the key steps. They identified the system area network. They developed their own I/O processor from scratch, from the silicon up, and they did their own systems integration design. The other thing is, unlike us, they have a long tradition of 5-year plans, N-year plans, and they stay the course, and they will do so here as well. They appreciate where they're behind. They have no doubt that through the procedures, the methods they've applied, that they will be the leader in this field before the end of this decade. With respect to the U.S. response, the U.S. is in deep crisis right now in terms of its federal strategy in HPC technology research. The Democrats don't understand technology, and the Republicans don't fund it unless it's funding defense research. Blue Waters will come online shortly, and it will act as a placebo. We'll again be at the top of the list, and we'll think we're doing fine, when in fact we are way behind in doing research for the future machines by the end of the decade.
Well, you actually bring up an interesting point. I haven't heard anyone all week claim that this top system on the top of the top 500 list is a more productive supercomputer at this point than Jaguar. There are a lot of new programming areas that need to be gotten into. Michael, is GPU computing the architecture for the future in HPC? If so, is it necessarily on NVIDIA? Does AMD ATI matter here? What do we make of Intel Many Integrated Core project for 2012 in this context?
That's a lot of questions all at once. So,
well, hit them.
Is GPU computing the wave of the future? It's interesting that the two announced 10 petaflop systems, neither one of them is using any sort of accelerator whatsoever. You've got the Blue Waters based on IBM's Power 7, and the Fujitsu K system based on their Spark V8, I believe it is. And they're both massively parallel and no accelerators whatsoever. I think a couple of years ago, if you'd asked, are we going to reach beyond 1 petaflop without some sort of accelerator, the answer would have been probably not. But we don't have any 10 petaflop systems designed with accelerators yet. So I think the question is still open. I've heard people say that, yes, we're going to have to use accelerators, and GPUs are the accelerator of the present, largely because they're free. They're paid for by World of Warcraft. So that's, you get what you get. Bill Daly had a very coherent and cogent argument about how he's going to be building machines at the petaflop, 100 petaflop, exaflop, exascale, using the technology they're developing for GPUs, and I think that's fantastic. But is it only going to be NVIDIA? Well, no. It's hard to make money betting against Intel. The mic is a fascinating architecture. It was supposed to be released as Larrabee middle of this year, last year?
At some point. It was coming. They were coy about it.
They were coy, but they pulled that project, but kept the technology. So Intel has several times has changed strategies dramatically in midstream, and they might do so again, but the mic is a very fascinating architecture and certainly has the potential to threaten NVIDIA's
Michael, I happen to agree with you. I think that's an interesting war being waged. It takes Intel a long time to turn the howitzer, but by the time they turn it and get it aimed, it can be a fairly effective weapon. But you skipped right over AMD and ATI.
AMD and ATI, right? They've got the raw performance.
And they don't have a software strategy.
Good things about the performance of these chips, but they seem to get lost in the conversation. Let's go back to the other side of the table. Your thoughts on this?
I largely agree with a lot of what Michael said, but I would say that GPU is not the architecture of the future. I would say it is an architecture of the future. I think we're going to have massive complexity, and certainly whether it's a GPU or whether it's mic or some other highly scalable acceleration technology, it will be in there. I expect them eventually to become part of the standard processor architecture in many cases, which will make them ubiquitous and free. And then the key becomes the programmability. I think CUDA's made huge strides. The work that Intel is doing in their research labs and has done, I think also addresses a lot of the problems of programming different methodologies, unifying sort of heterogeneous development environments for different architectures. I see the programmability as being the key.
Jay, your thoughts on the programming challenge here, the productivity challenge?
Yeah, so we support a few thousand users across our different systems, and a small percentage of them are doing GPU programming. Now, those that are doing it very effectively, but it is a harder programming model, and in a diverse user community, you'll always have some hardcore scientists who are willing to put whatever effort is necessary into getting maximum performance, and so we have them using CUDA, we have them using OpenCL. A much larger set think that, for them at least, MPI was hard enough, and they're looking forward to us providing more traditional systems that scale well. So I agree that I think accelerators are an architecture of the future, and I absolutely agree that programming has to be simpler to see greater adoption. I don't want to rule out AMD. I agree with everything my colleagues have said about Intel and NVIDIA, but if you think about it, Intel has the mic strategy now, and they're going from x86 towards accelerators. NVIDIA is coming at it from the other direction. AMD is not out of it. They've got tremendous position because they actually have both technologies. And I think we'll start to see the results of fusion and actually some more interesting things than that over the next 2 or 3 years.
Thomas, back to you on that same question.
With regards to AMD, don't count them out. There is always a role for a low-cost processor socket where products are low margin, and with Intel raising their price because they believe they're improving the performance to cost, AMD will still have a notch. Whether or not they get absorbed by China Inc. is another question. With respect to the GPU, it's the flavor of the month. We've been here before with attached array processors. Yes, heterogeneous will in fact be the architecture of the future, but not putting the accelerators so far away in latency and bandwidth that it requires Herculean efforts to program. What we will develop is a uniform execution model for a non-uniform system architecture that scales. That's when we will have arrived.
As we go through all the arguments against accelerators and GPUs, they're hard to program, they're not very productive, they won't work for all applications, ISVs have a hard time. I've heard this song before. We went through this when we went from SMPs to clusters, when we went from vectors to scalars. Thank you, panelists, for your views. Let's move to the next topic. Some